Thanks, Mike. Well, I'm really happy to be here, and thank you for help facilitating this really great event. As Mike said, if you don't already know me, my name is David Nads. Some of you guys might know me better as Dave Nads on the Twitter community. I like to start these presentations off, instead of talking about how many certs I have at the end of my name or where I work or where I used to work, about some fun facts about myself. So a couple facts about me. I was born with two uvulas. If anybody doesn't know what those are those red hangy balls in the back of your throat. I actually have two of those. My parents put me in special ed for a few years. I'm still trying to figure out why. And to Rob Lee's comment at the DFIR Sand Summit, I actually didn't ride the short bus. I did get to drive the normal bus to school every day. And I'm admitting here on the internet that I actually cheated on in high school in my C++ class. May have something to do with why I'm a Python programmer now. And as you can see, I'm actually dressing up as something for Halloween this year. Happy Halloween to everybody. I'm going to be a nerd, not real difficult. And I've only read one book in my entire life, no joke here. And sorry, Harlan, unfortunately it wasn't one of yours. And my favorite TV show right now is Real Housewives. So for the next few minutes, what we're going to be doing is talking about log-to-timeline. And what we're going to be doing is talking about large log-to-timeline data sets. I'm talking about gigabytes and millions of rows of log-to-timeline data. It'd be great just to kind of see by, pressing the hand button here, how many people actually use Christian's log-to-timeline tool. Great tool. So here's a picture of me and my cat Tony doing some forensics. It's the earliest picture we have together doing forensics. And I know it's probably hard to see, but I was actually running MacDaddy on this Apple IIe. And for anybody that doesn't know what MacDaddy is, it was actually one of the grandfather, or for lack of better words, the granddaddy tools for timeline analysis created by Rob Lee. This script would create an ASCII timeline of file system activity based on metadata. So, taking a look, fast forwarding a little bit in time, we have this amazing timeline creation framework today called Log2Timeline by Christian. And what's special about Log2Timeline is it not only parses out file system data, but it also parses out internet, prefetch, setup API, registry, event logs, and the list goes on and on and on. So ultimately you have the super timeline like you see here in the picture. And if this is totally new to you, the concept of timeline analysis and Log2Timeline, I really suggest checking out SAN's new 508 class created by Rob Lee. It really teaches the Log2Timeline and the timeline creation process from end to end. And the reason I say end to end, because I like to think even Alyssa, who I think is on tonight, she's a new, Alyssa Torres, a new SANS instructor, can even teach my cat Tony how to create a timeline. But the true art of timeline analysis, or science per se, is in your ability to interpret what you see. And the SANS 508 class does a really good job of doing that. So kind of applying this in the real world, Log2Timeline that is, let's run through a test that I did. So taking a source hard drive, 320 gigs that is, with about 100 gigs of free space, and running Log2Timeline on that, actually the Log2Timeline CIF command, which automates it a little bit, with the Windows 7 module. And what the Windows 7 module is a combination of a bunch of modules that all work on the Windows 7 operating system, and run that against an image file. On average, I get an output of an 8 gig CSV file, which on average equates to about 8 million rows of timeline data, timeline events. So, going into this test, I knew something about what I was looking for. I was lucky enough to have a date range. So I use another tool created by Christian called Log2Timeline Process, and I'm able to filter that timeline down to about 4 gigs based on that date range criteria. Now, I open it up in Microsoft Excel because that's the only method, at least that I'm aware of, that's efficient and robust for reviewing timelines. So I open it up in Microsoft Excel, that 4 gig timeline data, and what happens? Bam! You get an error saying, hey, this is way too big to open up in Microsoft Excel, and you're stuck. So the lesson learned here, at least for me, was Log the Timeline does this really amazing job of making timeline data available, but it kind of leaves it up to us as examiners to figure out how to review it. So kind of looking at the entire timeline creation process from end to end, there's really 4 components. You got to create your timeline, you got to filter it, and then you can present it, start reviewing it. But that filtering and presentation really becomes an iterative process as you can only bring in so much into Excel. And that really kind of starts to make your head spin if you're doing timeline analysis a lot. And there's a lot of other deficiencies, but you know, there was a lot of room for improvement as well. So this is where I started thinking what I would really love to do is merge that filtering and presentation together into one tool. And that's what kind of gave me the idea of Log the Timeline Review, which I'm going to show you in a few minutes here. So what Log the Timeline Review is a tool that I created over the last 12 months. I've taught myself Python, not Perl, in part of this process, WX, which brings us all together in a GUI, and SQL, actually SQLite as a backend to this tool. And what Log the Timeline Review allows you to do is import your Log the Time CSV files into Log the Timeline Review, into the backend database, and use a GUI very similar to Microsoft Excel with all the similar features plus more that you're accustomed to using Microsoft Excel, such as filtering, searching, tagging, commenting, auto-highlighting, and also some other really cool stuff, including charting, which I'll show you in a few minutes here. So let's take a look here at what this actually looks like. So I'm going to compile this. The way I distribute this tool is actually in a binary, so you don't have to worry about downloading Python on your computer or any of the dependencies that are required for executing it or compiling it here. So I'm going to just execute this from source, but for you it'd either be an exe or a .app if you're on an OS X, and I'm also working on creating a binary for Linux as well that'll probably be included in the SIFT workstation down the road here. So this is what the GUI looks like. Hopefully everybody can see this. Real simple GUI. Kind of the step one is obviously to bring in your Log the Timeline CSV file. So we're going to start there. You're going to click on File, and you're going to click on Create Database from Log the Timeline CSV file. And I already have a CSV file, not very big here, just because I didn't want it to take very long to load. So we're going to double click on this. Now it's going to say, hey, where do you want to save your Log the Timeline Review SQLite database? So I'm just going to save it here in the default folder. Change this to 4. Press save. Now it gives me the option to filter data on input. So say going into this, if I'm absolutely certain that the events that I'm interested in analyzing are between a certain date and time, I can enable a date filter and only import certain events based on that criteria into the database here. So I'm going to press OK. Now this will give me the ability over here on the left to kind of choose what index fields I want to do manually. If you're kind of a power user of the tool, you may select your own. Otherwise, I just suggest clicking cancel and use the default index fields. And what this does is just create the database by importing the Log the Timeline CSV file into it. It's pretty quick. As that's going, I'll kind of just give you an overview of some of these different panes, the various panes here in the tool. You have your filtering pane here on the upper left-hand corner. What this allows you to do is visually create SQLite queries to query and filter the database. Down here is the ability to import save queries and also save queries in your database. this is useful, or at least useful for me for queries that I don't remember often, such as like event logs. So what I've done is I've actually created saved queries for every single event ID for Windows XP 2003, Windows 7. So if there's a certain event that I'm looking for, I just go and import it, and I can run it. Before I move on, you see here that you get some feedback when you finish importing your CSV file. It tells you how many sources you have and the frequency of those sources, the start of your timeline, the end of the timeline, how many hosts, and if you did have a filter, how many events were excluded. So I'm going to press OK, and what it's going to do is automatically open the database. Up here is my display controls. This allows you to insert a custom query up here and also view the query that you're currently running. Clear the grid view page between results. This is some cool charting that I'll show you in a second. This is the display grid view, which will display your grids responsive to any queries that you run. And down here is your review pane. This allows you to create tags, insert comments, and actually bookmark events as well. So now, since we have some data loaded in here, I'm just going to show you a couple examples of what things look like if I were to run some real basic queries here. So I'm going to select web history. This allows me to select all the common log to timeline CSV files. I'm going to click add, and what this is going to do is create a filter to show me all events equaling web history, source events equaling web history. I'll press filter. In a matter of seconds, I went from 11,000 rows down to about 1,500 rows. And the results are presented over here in the data grid view. Once they're in the data grid view, I can highlight just like I can in Excel. I can hide rows if I'd like. I can hide columns as well. It's all filterable. You can slice and dice this data just like you can in Microsoft Excel. I'll show you what the all timeline activity looks like. This chart here. I'm going to clear the grid, enable it, press filter. And now what we have here is actually a timeline of all the events that I have in my data grid view. So what I can do, because obviously there's a lot of them here, is I can zoom in and I can see the frequency of the events based on the date and times. And all these panes are adjustable, and not only are they adjustable, but they're undockable. So I can undock these panes. So if I have more than one monitor, I can put the data grid view and blow it up on monitor 1 and have my filtering pane on 2, and then on 3 I can have my review pane, which is really nice. So a really cool thing about this charting right here is it's interactive. So if there's a bunch of events on a certain date and time that's of interest to me, what I can do here is I can click on this, and it's going to automatically update the data grid view to show me the events that occurred just on that date, which I think is pretty cool. So we can clear the grid here. Just so as far as filtering goes, it's pretty advanced. In terms of logic, you can and or things together. We also have color coding, so you can color code based on host. So if you have more than one host in your database, so let's say I just imported a log to timeline CSV file from host 1, and now I just came across another host that may be compromised. I can insert, I can actually append right here another log to timeline CSV file into the database. So obviously you don't want to get confused from the different hosts that you're reviewing, what events are from what hosts. You can look at it from the source or the file name to kind of see where it's coming from in the data grid view, but a really easy way for me to distinguish between different hosts is by color coding. So you can color code your hosts. You can either use automatic coloring, or you can define your own colors up here in settings, right there. Or just like the Rob Lee's Excel auto highlighter, you can sort based, you can add highlighting based on type as well. So a lot of really good ways of filtering your timeline data up here. And if this isn't enough for you, any combination of all these different events, you can always create your own SQLite queries up here, or you can further redefine queries, existing queries that you built up here. Another really cool thing about this tool that I think kind of really takes it to the next step, timeline analysis, that is. Let's see here. Let's go to source. Let's find some files, and let's try find some file names that are responsive to .doc. So we're going to search the timeline here for all files, file type sources, and any file name that contains .doc. So we're going to try to find all the .docs in this data set. And I'm going to press filter. It says there's quite a few of them. Okay. You know what? I forgot to press and here, so it's going to show me everything that's file and a .doc. So we'll let that load and we'll reset that. But you can see the speed of that. That was 27,000 results that came back. Pretty quick. So now we're looking at all the .docs, and we can verify that by looking at the file name here. So taking timeline to the next step, what happens, I see this file, maybe it was transferred to a USB device, and, I want to know what this is. I don't want to go into NCase or, back to my SIFT workstation and, have to manually extract this file to see what this is. I want to see what it is from right here inside of my timeline review tool. So what I've given you the ability to do here is link your timeline back to the host image, back to the source, that is. So the easiest way to do that is to, at least for me on Windows, this also works on OS X, is to just mount the disk image. I like to use IMDisk because it's a free tool. So I'm going to mount that, assign it to a drive letter, and then I'm going to go up here to settings and go click on image path. And I'm going to select the image path for the drive that I just mounted. I'm going to press OK. And now what that gives me the ability to do is invoke a file viewer. There's the file viewer. And this file viewer supports thousands of different file types, hex, different file types, and also different views: hex, text, binary, Unicode, Microsoft Office views you're looking at right now. So that's really, really cool. Another thing what I've given you the ability to do here is right-click and hash a file. All the time I'll come across, an interesting binary or PDF file, and I want to see if it's malicious. And the easiest way for me to do that is perhaps, get an MD5 hash value of it and, send it up to VirusTotals. Well, now it's just a matter of right-clicking, produce MD5 hash value, going to VirusTotals, and entering in the MD5 hash value. If I want to, at any point in time, I can create a tag. Let's say that file is interesting. Ask Rob Lee what this means. Maybe I don't know what it means. I can select my tag, and I can tag it. And you can see the tag in the database. I can filter by tags. I can insert comments here. And all this stuff is automatically being saved in the database. So if you close it, open it back up, it's still going to be there. And the same applies to highlighting, which is really cool. So if I highlight something in this view, and then I go do another query over here, and I had previously highlighted something and it appears again in the data grid view, that highlight's still going to be there. So all highlights are persistent in the database. One last thing, because I know I think I'm running out of time here, that I'd like to show you, is a dashboard view, which I've been working on. So in addition to being able to slice and dice the data here, I've given you the ability to slice and dice data using a dashboard. So anything that's being displayed in your data grid view, you'll see on the dashboard. So you'll see, for instance, I only have one source type being displayed in my grid view. One source type, one user, one host. These are the different MACB properties. You know, I have a couple different tags currently in this data grid view and only one color. And I can click on any of these and it'll automatically bring me into that. So that's interactive as well. So for me at least, when I'm doing timeline analysis, it's easier to see a picture than it is to read things line by line, at least when I'm looking for certain types of data and trying to drill down to certain source types. So I've added that capability as well. I haven't looked at the questions, so let me take a look at those real quick. Is there any plans to import the hash value straight into VirusTotal? Asks Corey. And yep, absolutely. I'm planning to do that here in the near future. Where is this tool available? So let me get back to my slides here. So right now it's still in beta, but I have probably over 50 people using it, and really haven't reported any problems. If anything, I'm just making feature enhancements at this point. I'm really looking forward to the release of Log the Timeline in Python, hopefully here in the near future, because what that's going to allow me to do is give you guys the ability to not only review your timelines in Log the Timeline review, but also create them. So use one tool from an end-to-end approach. As far as the release goes, I said at my DFIR Summit SANS 360 presentation that it's going to be open source to the private sector, but law enforcement's going to have to pay for this one. I was just joking. Well, maybe I wasn't. But the beta is available to anybody. Here's a link. I'll post a link here in the window, so you can request a download. And a license to use it. It's going to be free at no charge, and that's it. Let me just make sure I wasn't missing any questions here. What UI library are you using in Python? I'm using WX widgets, and I think that's it. Well, thanks a lot, Mike. I appreciate the opportunity to come online here and show you guys what I've been working on, and feel free to download it and play with it, and if you have any feedback, let me know.
And that is just beautiful. Work of art.
And I can't thank Christian and the guys at Google enough, because they created Log the Timeline, and if it wasn't for that tool, I wouldn't be able to do what is that I'm doing here today. So thank you, Christian, and all the guys at Google.
Yeah, well, we do have a couple of other Googlers here tonight, so it's just mind-blowing when you find out the stuff they do in the background really quietly. The Google guys just do this fantastic stuff. But man, I think the thing I love about it is it's so obviously written by someone that's actually using the tool and doing real investigations.
Yeah,
you design,
and that's
exactly.
And when I first had this idea, I was considering hiring a programmer and actually paying somebody out of my pocket to do this. And I actually went as far as talking to some people, but every single person that I sat down and talked to about this idea, they were like, image? What do you mean an image has data inside of it? Referring to an actual hard drive. Nobody understood what I was talking about. What I really needed was a programmer that, not only could program, but understood forensics. And I just couldn't find that combination anywhere. So that's what really led me to the initiative of learning Python, SQL, WX over the course of the last 12 months, and just doing this myself on my spare time and weekends.
That is dedication.
But
that's awesome.
Thank you, Mike. I appreciate again the opportunity to be here.
Yeah, man.
And
Thank you.
hopefully everybody enjoys using the tool.
70 odd users now. Awesome. Okay, Joachim.
Yeah, as Dave pointed out, we're dealing with a lot of data, and especially for log to timeline. And I'm going to talk about giving Dave even more data to deal with in this new tool, which is having the volume shadow capability into log to timeline, and hopefully more extensive XML event logs. This is something I've been working on for quite a while, and both of them are still a work in progress. First of all, for those of you who don't know me, yeah, my name is Joachim. I'm currently working at Google as part of the incident response team, and I am the author of a lot of different projects like libewf, libevf, and much more, which I can hardly keep track of. So I created the website libyal, which stands for yet another library. If you have ideas, contact me or put them on the project site, and who knows, maybe one day when it's raining outside, I will create a library of it. That brings me to the why I created volume a library to deal with volume shadow snapshots. First of all, using Windows is a large manual hassle. You have to link the devices, and you have to check manually which device number they're using. And the second point is that basically you don't have any control over the system and how it deals with the volume shadow snapshots. Volume shadow snapshots are managed by a kernel level subsystem, and even if you connect a write blocker, it can still make changes on the fly without writing them to disk, but keeping them in memory. So you have no guarantee on fully preserving the system state of the snapshots themselves. And for those of you who didn't see my presentation at the Open Source Digital Forensic Conference, I also found an interesting side behavior of the volume shadow snapshots devices on the Windows. Namely, that imaging tools will show a block wrap behavior when imaging certain parts of the device on Windows. For more information, I'll refer you to the paper and presentation I did at the Open Source Digital Forensic Conference, which can be found on the project sites recently. So what is libvshadow? It's a library, and the package comes with two tools. In this case, vshadowinfo, which for those of you who are familiar with vshadowmount, is basically shows a similar information as vshadowmount list shadows. And the second tool it comes with is vshadowmount, which is a mounting tool on Linux to mount the volume shadow volumes as fuse handles, so you can inspect them with the sleuthkit, for example. Some background information: I started this project in March 2011 before I joined Google, and I mainly started it because of lack of good tools that could do offline parsing. Also because I wanted to understand the format into a better extent. I recently provided a presentation about my findings of this project at the Open Source Digital Forensic Conference. And last 2 weeks, in the meantime, I've created Python bindings for the library, so it can be used in the upcoming new version of log to timeline, which will be written in Python. For those of you interested, the project can be found at the project site mentioned below. To give you an overview of how the tools operate in action, here you can see vshadow. As I said, it's basically the output is similar to vshadowmount list shadows. You can point it directly at an image or at a device handle if you want. You can specify an offset, and it will print the basic volume shadow information. If you want to do something useful with those volume shadow volumes, you can use vshadowmount. You mount the image at a certain mount point, and as you can see, I put in this case two images side one another On the left you see an FLS of the first volume, and on the right the second volume. On the left file 2 exists, on the right no longer, and on the right a third file has been added. If I want to recover that file 2 which has been deleted in the meantime, I just can run the normal sleuthkit commands on the specific like a specific volume shadow volume. But having volume shadow capability is one thing. Another annoying thing of having to deal with Windows is the recent change of event logs, and I rarely found any good tools for it except for Andreas Schuster's tool, but alas, it's written in Perl, so it's hard to integrate it in non-Perl code. Windows does a fair job with event logger and log parser, but again, you're bound to Windows. And I never found a real good analysis of how to deal with the formatted messages in EVTX, how to deal with message recovery, and limited work has been done on automated analysis of event logs, and that decided me to write a library for it with, in this case, corresponding tools again. You're probably familiar with the naming scheme EVTXinfo and EVTXexport. This code has not been released yet. I'm working on an experimental release and hope to push it soon to the project site. So if you're interested, keep an eye out on the project site. Hopefully it will be an experimental release will be up there soon. To give you an idea of how I intend to create the tools, I'm not showing EVTXinfo, which just provides basic information of the EVTX file, but it can be useful to test for corruption and that kind of stuff. This is EVTXexport. You're probably all familiar with the XML output file, which also is also created by Andreas Schuster his tool. In this case, -f specifies the format, and you only need to specify the EVTX file, and it will dump the EVTX events in XML, which is largely similar to what the Windows XML will look like. I'm trying to keep that as close as possible to the Windows to minimize other tools that can parse the format to deal with yet another implementation of it. But before I get to the formatted messages, showing you the formatted messages in EVTX, I first have to show you how it's done in EVT. Normally EVT, the predecessor of EVTX, you had the event file, you needed the software registry hive, you needed the system registry hive, and you needed so-called message files to get the eventual format messages. So what do you need from the software registry hive is the system root environment variable. You needed the system registry hive to get to the message file, and this parsing is, at least for EVTXport, not EVTXexport, done by the registry library I wrote a while ago called libevtx. And if you have the information from the system file, you can use that to find corresponding Windows executable files that actually contain the message strings. And for this, for libevt, I wrote two separate libraries for this, libexe and libwrc, and the latter one stands for the Windows resource format. If you have that information, you can get to the message string inside an executable, and that message string will contain placeholders, normally %1, %2, etc. And you use this information and these strings in the event to reconstruct the original message. So the event file itself doesn't contain any formatted messages, it only contains the values you have to put into the placeholders. But this behavior changed in EVTX. On Vista, they introduced something called MUI, which stands for multi-user interface, and it's used for multi-language support in Windows. So our event message file no longer, which is our PE.conf file, no longer contains the message strings itself. it actually redirects to a language-specific PECOF file, which contains the actual strings. So you have a separate, now you have a separate file for every different languages. In the past you had one file containing multiple languages, now separate files per language. It's, on one side makes sense, another side makes the processing more harder, because now we have to deal with yet another processing case, namely, as you can see at point 3a, the path has changed, but the registry file will still point at the original file. Another factor is the event identifier. For those of you familiar with the XML output, you will see that the event identifier sometimes comes with a qualifier and sometimes not. To reconstruct the event identifier that is necessary to get to the message string, you have to combine both the qualifier and the event identifier into 30-bit value, and then you can look that up to find the specific message string. Another thing that has changed in EVTX is that the strings and the data, which in EVT were separate, are now combined into one event data section, but they still behave similar. So the idea for EVTXport with the formatted message support is to work as following. You specify the format text. You specify P1, in this -P stands for the mount point, or the path where it can find the executables. The R points to the path where it can find the registry files, and then it points to the specific EVTX file. And as you can see in the output, it will dump the event information largely as Windows Event Viewer also does. I've left out the message string itself because that's something I'm still working on and hope to complete soon, so I can put up an experimental version of the EVTX tools up to the project site. And there's also work going on for Python bindings, so also that will be integrated into the new log to timeline. A quick overview again. libvshadow, I'm working towards beta. What does it entail? I'm mainly adding automated testing and hopefully some useful test images. Once that's done, I will move to beta. The project site, as mentioned, there is where you can find the code. libevtx, I'm working towards experimental release. The project site, what I'm still working on is formatted messages. I'm largely getting there, but there are some scenarios I can't deal with yet. One thing also for log to timeline is creating an offline database of the message strings, so you don't need the image or the executables present to get the formatted messages out. And another thing to deal with is the preferred language, especially when you have dealing with systems that are non-English. It can sometimes contain multiple languages, and if you're not a native speaker of that specific language, it's pretty useful to have the information largely in English. And for other stuff, I'll refer to you to the libyal yet another library project site. I don't know, anyone questions? Let me see on the chat.
I think there was questions. Dave was still running conversations for his stuff. I didn't see any questions
Okay.
come through here. It's good to see some in-depth discussion on file format. Sorry, I put my webcam on.
And if people have questions, they can always contact me afterwards at the email I gave in the beginning.
At the beginning. Okay. I'll be, is our recorded? Actually, I haven't checked if it's okay with you guys to be recorded. I will be double checking that it's okay to be recorded, and I will be posting the videos later on as well. Yeah, and Hal, that's right. Joachim's just written all this stuff. It's awesome. So, thank you very much once again.
No problem. Thank you for having us.
We got you before you left the country, so you're still in a reasonable time zone. Unlike Darren, who we will bring up next once I find his share.
Yeah, bye. I'll stick around for Darren's talk anyway. But
okay, thank you, Joachim. Okay, Darren, I'm just going to close that one.
Okay, can you hear me? Can you see my screen?
Man, I've lost it. Okay, at the moment, there we go. That's there. Now I've got to get these other ones out of the way. Hold on a sec. Too many screens. There we go. Now everyone needs to realise that Darren is in Zurich, where it is 2 o'clock or nearly 3 o'clock in the morning. So he's dedication here. So thank you very much for coming on, and I'll just let you get started.
Okay, cool. I'll try and keep awake. I've had coffee, so we'll see how we go. So I guess the plan here is to talk about GRR Rapid Response, which is a tool that we've been working on for a number of years now in the team, and we've finally got it to the point where we think it's almost ready for human consumption out in the real world. And so it's basically an automated live response tool for dealing with things at scale. And so I'm going to talk through, I guess, some of the details of it, and then we'll do some demos, and I'll try and do some live demos, and we'll hope that they don't go terribly wrong. And I guess I work at Google as well, where I'm tech lead for incident response and for forensics. So, okay. So first up, kind of the use cases for this tool to try and give you some context as to what it is before I start to describe it a little bit more. The idea is that we're trying to go for remote forensic acquisition of machines. So we need to be able to, if we have machines that are remote, we need to be able to pick up kind of disk and memory remotely. We need to be able to investigate machines even if they're remote and on poor bandwidth connections. So if somebody's, in a different country, or whether I don't want to have to fly there to deal with it. So I need to be able to, remotely analyze them. We also need to be able to check large numbers of machines for known indicators of compromise. So if we have a large environment, kind of hundreds of thousands of machines, I need to be able to deal with that if there's something I need to look for. And also we want some sort of tool that also allows us to test hypotheses about our environment. For instance, if I want to find out something get me all the executables that start from app-init, DLLs in the organization, and then I can do kind of a statistical analysis of those. And so these are kind of the use cases that we see Go working for. So to talk a bit about the things we want, we investigated a number of different tools before we embarked on this, and started thinking really about what we really wanted in a live forensics tool and live response tool. And these are kind of some of the key things that we came up with. One was that we wanted our open tools to be enterprise capable. So we use, obviously, log to timeline, sleuthkit, and all these other things that probably people are pretty used to as far as open source tools go. And the problem is that they're fantastic for dealing kind of with one machine or dealing with a reasonably simple case, but it starts to get difficult if you want to expand that to a lot of machines. We also needed remote access to investigate machines. We needed to scale pretty well. It needed to work over the internet securely, so we have an environment where not everyone is connected all the time, and so we need to be able to handle things over the internet. And that obviously invokes a whole lot of security requirements for how something gets built. And then we also need to work across OS X, Linux, and Windows. We're not just a Windows shop. And we obviously need support across those things. Additionally, we want automation to be easy. So if I do something on one machine, I'd like to be able to do that on all the machines. And secondly, if I'm scripting things and trying to automate my work, I really don't want it to just be tied to a single vendor's product. I want to be able to move products, and ideally to be in a language that I like Python. And additionally to that, we kind of wanted something that could potentially be our memory. So we wanted to remember the details about artifacts. So one of the problems we kind of find with forensics is it requires you to know an awful lot, right? It requires you to remember all the registry keys that you want to take a look at. It requires you to take a look at a whole lot of different things. You know, you need to know all the artifacts, you need to remember what they are, you need to continuously read about things and learn about things constantly to stay up with the player as to the things that you can find. And you need to know the anomalies, right? You need to know, like, in an event log, well, these entries are bad, these entries are normal. So ideally we'd have some sort of tool that could do some of this for us. We'd also like multiple people to be able to work a case at once, and also we want it to be customizable. So we don't want just, in this case for live forensics, the standard mechanism is that you deploy an agent to a system, and then you use that agent to do a whole lot of things for you. But what we don't want is we don't want to have to be stuck with a single agent that everybody in the world is running, which makes it very easy for attackers to recognize you and to deal with that. So we want to be able to do something custom across our different systems and really be able to respond well. So what we wanted is something pretty awesome, with kind of sharks and dinosaurs. Unfortunately, what we built is something a little bit more like this. And so I guess this is just to set expectations that what we have built that doesn't do everything, certainly not yet, but hopefully it does some of the things that you want, and I'll talk through what it does do. So what we built is an agent-based system. So it runs on Windows, OS X, and Linux. A very simple executable that you can run on any machine. Has basically no dependencies. It communicates over the internet securely using HTTP with encryption. We've got a scalable backend. We've got an AJAX web interface. It's completely open source. Uses Mongo as a backend and Python compiled to things for the clients. And I guess the most important thing is that it enables most common live incident response and forensics tasks. So hopefully that means it will be useful to some people. So maybe what I'll do is I'll try and do a demo of this, because I think it's probably the easiest way to give people an idea, and I guess people can throw me questions as I go through the demo. I'll carry on with some more information about it once I've done the demo. But let's see if I can switch here and everyone can still see it. So I'm not going to do an install here because that involves changing to VMs and all those kind of things, which is going to get a bit messy. But what we have here is, this is the user interface. So I have a search box at the top. I can search for the machines. In this case, I've only got 2 machines connected. It's not as impressive with only 2 machines, but you can see here we have 2 machines. One is online at the moment and one is not. So I can select the machine here. And then what I can do here is I'm now connected. Remember, this is an agent running on a remote Windows machine somewhere out on the internet. And what I can do is I can start up some flows to do some things. Now, in GRR, the basic unit of work is what we call a flow. And the idea is that a flow is something on the server side that can do a whole lot of work. It can ask the client to do a whole lot of things. It can process data. It can pass the data. It can then decide based on that data to ask the client for more data. And so it's kind of this workflow thing, and you can build more and more complex flows as you want. So in this case, we're going to kick off some pretty standard things. I'm going to, let's say, am I going to have a demo problem? Let's hope we don't have a demo problem. Oh, come on. Okay, I'm going to have a demo problem. My apologies, we might have to switch to video, but let's just try this. Okay, let's do video. Let me just stop sharing and I'll switch. Okay, so with any luck you can now see the video. And I guess to answer your question, JJ, yeah, you have a server on the network, so it's separated out, and you have basically one machine that needs to be exposed to the internet on one port that can handle the communications. Okay, so if you can see the video, I guess I'll use the video for this because either Amazon AWS has gone down or something's dead. So in this case, I'm going to select the machine, and in this case, what we're going to do is we're going to start by launching these flows that I just talked about. So we're going to do some automation flows. So the idea of an automation flow is to do all the things that you might commonly do. So if you're starting to investigate a normal Windows machine, there's a bunch of things that you want. You know, you want the event logs, you want maybe some data about the antivirus, the prefetch, a bunch of other standard things that you want. So we'll kick off one of those, kick off a browser. In this case, I'm going to ask it to collect the Chrome history for the user test. And now what I'm going to do is, in the background, these requests have been queued up for the client. So the client's checking in regularly. It's going to have some work to do, and we'll pick up and start processing those requests. In the meantime, I'll explain a bit about this, what we call the virtual file system. So in GR, we map pretty much everything into this virtual file system. So you'll see here we have the virtual file system using TSK. So you're essentially seeing the file system through the view of the sleuth kit. So you'll see here that we're viewing the entire file system. You can actually see, you know, $MFT, which you'll know if you use the sleuth kit. And effectively, you can retrieve any of these files or list them or do all the normal things that you expect to be able to do with files, all via this VFS layer. And then we also have the OS layer, so this is using the Windows API to request those things instead of using the sleuth kit. And then you also see that we have the registry. So the registry again is mapped into what we call the VFS, such that you can just browse it as a normal registry, just like a file system, and see all the files that you want to collect or retrieve. So I'm just here. We'll go back to the flows that we've already launched. And you can see some of our flows have completed here. We get a notification that the flows are completed. And we can click on the notification and kind of jump to the analysis. In this case, this is our Chrome history. And we can just select the Chrome history, and you can see it in a text view. It's a pretty basic CSV at the moment. So you can see the Chrome history gets downloaded, passed, and then given to the analyst. Okay. So one of the other things that's great about GR is that we actually ship volatility with it. So if you're not familiar with volatility, you probably should be. So volatility is a fantastic open source memory forensics framework. And using GR, we actually ship some open source memory analysis drivers. So the drivers that can do memory acquisition. And we ship these with GR. And effectively what happened here when I run the volatility plugins is we're actually sending the driver over the network to the client. The client loads the driver, and then we're shipping off a bunch of volatility commands to ask it to access the system. So in this case, we see it completes pretty much immediately. And from here, I can jump and actually take a look at the analysis that it came back. In this case, we ran the PS list, DLL list, and modules functionality. And you can see here that we get back. At the moment, it's pretty raw, so you get back pretty much what volatility sends. So just pretty much the raw output as if you were running volatility on the client. But we have plans to parse this more intelligently so you can get more structured output. But yeah, that gives you, I think that gives you a reasonable overview of at least how the UI looks for working with things. So let me try and switch back. Let me see if my demo's come back to life. It hasn't. Okay, fine. So that's a basic demo. And, I just want to talk a little bit now through, I guess, some of the design decisions that went into GRR. So one of the key things is this idea of thick clients versus thin clients. So you kind of have the option when you're building something like this as to where you want to put the intelligence. And one option is, of course, to make the client really intelligent. So you can ask the client kind of complex things and say, please tell me if any rootkits are installed, for instance. Or the alternative is to put all the intelligence in the server. So we actually do this in GRR. We put most of the intelligence in the server such that the client is reasonably simple and therefore easy to maintain and therefore easy to upgrade without concerns. And so we keep most of the intelligence on the server and then push these flows control all the intelligence. And that allows us to really change things. So while the client supports very raw things like reading files and reading raw blocks off disk, the server can build upon those things to actually do really intelligent things without having concerns about the client. Additionally, we do this thing called asynchronous flows, and this is actually explained in the DFIRWS paper that we did. But the idea with the asynchronous flows is that everything happens in parallel, and this really allows us to scale really large in terms of the number of clients that can work. And it allows us to, again, that intelligence is kept on the server, and we know that even if we have a lot of clients, they're not holding resources when they're not doing anything. And then additionally, we do this thing which I think is kind of unique in GRR, which we call basically using the axes of time. So the idea is, obviously, when you're doing live forensics, you kind of have this smear of things that you collect over time. One of the nice things with GRR is because you can scale up the storage as much as you want, and because you can snapshot because it's a live client, you can actually grab data regularly. So we can do things like grab the process listing or grab the list of mutexes or grab pretty much any piece of data that we really care about and then kind of retrieve that data regularly. And then that gives us kind of the snapshotting ability, so we can go back and say, well, what changed in this week? Or, what's new on these systems this week? And that ability to really see what's changed and look back in time and see how things have evolved helps you a lot. And also helps you with things like if people are using timestamp tools or these kind of things. Because you have the history of what was actually there, you can really range those ideas. I see Bruce Elliott has his hand raised. Somebody have a question? No? I'll carry on. So I'll skip over these. But yeah, the historical record of artifacts. So one example of this is, you can potentially do things like keep a record of all the boot sectors in your environment. Just in case one changes, you actually can go back in time and see what it used to be. You can actually see exactly what changed. And, we can keep as much history as you have storage. You can potentially keep, history of memory images or something like that if you were feeling pretty brave. This is just a console screenshot showing how you can, I guess, diff the processes, but I won't go too much into that. So we have Windows, Linux, OS X clients, open source memory acquisition drivers. We use volatility. It has a secure communications. We can do client auto updates. And I think it's worth saying that this is built and tested to run in real enterprises. So this isn't just, we hacked up a script and it kind of works. It actually works on real clients and can be run, and you can actually convince real operations teams to install it, which is kind of handy. And I guess the features that you expect, you can retrieve files, you get raw file system access, you can do memory acquisition, search memory, do memory analysis, you can timeline events. So at the moment there's not log to timeline integration, but you'll see that coming. One of the reasons we really wanted a Python log to timeline. You can schedule recurring actions, do reporting, all those kind of things. And one of the things that really is kind of big about this is the ability to do what we call hunting. And hunting is pretty much the idea of when you have an idea of something that you want to look for, it's applying that to a large environment of machines. So applying the same flow that you normally do. So I want to see if this registry key exists, or I want to see if this registry key and this file exists, or I want to see if this string exists in memory and that string happens to be in a process that has these properties. And so being able to take that and then run that across, a large environment and be able to get the results back in kind of, depending on which clients are online. But for the clients that are online, getting all those results back in kind of 30 minutes. So let me try and give, just in case this is working again. I installed this on Amazon about half an hour before the presentation, so I guess it shouldn't be too much as a surprise that it failed. But, okay, let me do video again. Okay, so can anyone see this working? Hopefully you can see the presentation. Okay, so in this case what we've done is I've created a hunt. In this case it's pretty simple, and again we're working with 2 clients here, so it's not particularly impressive. But we have a kind of a Linux box and a Windows box on here. And we're doing an MBR hunt. So in this case we're collecting the master boot record off the 2 machines. And so here we define a set of rules that say, in this case, it can run on Linux systems or Windows systems. We get an overview. In this case, it's run, I think we see completed on 2 clients, out of 2 clients. And one of the things that you'll notice here is you can actually see the total network traffic generated by this, and you can also see the total CPU seconds generated. So that'll be important, and I think probably to answer one of the questions that's in there at the moment. So you can see in this case we've got it completed on 2 machines, and we actually have you can see we actually we keep track of exactly how many CPU seconds it used on each machine, and exactly how many network bytes we sent on each machine. We also track the I/O usage on the machine as well, and this allows us to historically go back and track and see if our memory usage is getting out of hand or any of those kind of things, which is pretty valuable. It also allows you to do things like you can run the hunt on kind of 50 machines first, see what the impact is, and then if the impact is okay, then you can you can decide to run it on the whole fleet if you wanted to do that. So here you can see this is the MBR that was collected off the system, and like every forensics tool, we have a hex viewer. Because everyone likes to view things in hex. So in this case, yeah, you can pretty much pull data, pull any data you want, and then do that across the whole system. And the nice thing about that is once you have it running, obviously you can take that data and then process it any way you want, because all that data is now stored on the server. And so do I have anything else to say? Yeah, so I guess roadmap, we have a long road ahead. We're doing lots and lots of testing at the moment. We have a lot of work to do on the UI, as you probably noticed, but there's a lot of things going on there. We've got timelining coming, and some more of the artifact passing kind of stuff, and trying to simplify the management of getting it installed. There's basically a deb file that people can install at the moment, and all the clients are up on the site. There's a lot of contributors to this, so obviously we have a lot of open source developers at Google, and we have a number of full-time people now actually working on this project. And it's built on tools we know and love in open source. And I guess the status, we're calling this alpha at the moment, which is that it is ready for brave souls, not for everybody, but we think we're getting pretty close to the point where we're only, at least at the moment, the server requires Linux, so you'll need some knowledge there. We will probably get to the point of trying to release a server for Windows, but obviously given that this is part of the design here is to be able to scale and do those kind of things, I don't expect people to try and do that on Windows, but we'll see how that goes when we try it. There's a live demo that anyone can kind of go and click around. It's not a full demo, but it should give you enough. You won't be able to do the memory forensics and that kind of things on it, but it should give you some idea of at least the user interface. Things are pretty well documented and getting there, and the code is there for anyone to try. So that's me. Anyone got questions?
If local resources like CPU and memory can be easily managed.
I think Joachim was sort of answering questions
to minimize the press of the client.
As things.
Right. So yeah. So at the moment we haven't put throttling in. We have this idea of like being able to set the priority on things, which will lower the impact on the client. But we haven't actually done, we have this idea of a limit where you can say you can't use more than X CPU on a machine, which will stop it from kind of going out of control. But we don't really have the idea of throttling at the moment. As far as the install goes, the install can be pretty much, the install is silent. You run the executable and it's installed. There's no UI or anything else. And yeah, that's all, I think. Yeah, I mean, there's nothing to do as far as the...
Awesome. Well, thank you very much, and especially given the ungodly hour that it is there at the moment. Very dedicated. It's good to hear. Yeah, good stuff. And good to hear a nice southern accent too. Real southern accent. Okay, so this is the last one. I'll just get my desktop up, and hopefully that's coming through. Can people see my desktop? Cool. Okay, so what we've got here is something that just doesn't look anywhere near as nice as anything else we've seen so far this evening. But it does serve its purpose. And basically what TAPEWORM is an automation engine for basically pre-processing your jobs. Whether you call it triage or something else, I would be more inclined to say it's a bit more in depth than that. But basically all it does is provide you with a single interface to run this collection of open source tools. So we run Logs Timeline, run XFTool, multiple antivirus scanners, bulk extractor, Redripper, carving. At the moment we have Foremost. We're going to be putting in support for PhotoRec as well. And this funky little script that's also been developed called Identify Files of Evidence, which I really want to turn into a Find the Evidence button, because I just think we need a forensic tool that has that. So the idea here is that, and this is the brainchild of Doug Costa over at Task, and basically he does a huge amount of dead box stuff, and a lot of his jobs are ones where he knows nothing about the box. He gets a hard drive, it's like find all the evidence on it, what we would have called a fishing expedition. when I was with the cops, where you just, oh yeah, there might be some evidence on there. You're a computer bloke. You go find all the evidence for us on the system, and we really don't know what we're after. So kind of like shotgun forensics, where you're just trying to go out and get everything. So he started out writing a bunch of scripts to automate a lot of the stuff he was doing all the time, and then found, all these tools are obviously Linux tools. He's trying to share his stuff with a bunch of people that were not necessarily terribly strong on Linux and command line stuff and things. Sort of, some people aren't quite as comfortable with as they could be. So he thought, let's create some sort of GUI interface to make our life a bit easier, which is when he sort of approached us at the college and said, look, could you do that? And we had a bunch of students sort of working on it over the summer, and this is what we came up with. So I'll just start up a new instance of it so you can see. So, I mean, really simple. Type your name in, type your case number in. You can process a disk image. You can process a folder. You can look at a single file, or it'll do a logical evidence file. At the moment, logical evidence is only the encase LO1s. We're not supporting the FTK stuff, or exit starter stuff yet. You then go through, load up your evidence. I would grab whatever I wanted. Sorry, I should go logical evidence there. I'll try disk image. So load up your evidence. Tell it where you want the output to go. So in this case, just using the share with VMware. So this is just all running in a VMware virtual machine. Tell it where you want the output to go and select what tools you want to run. Solve case and write report. Yeah, haven't got to the report writing yet. Unfortunately, this still requires a certain amount of human interaction. We're just bulk processing the easy stuff. And then, so for each of these options, once you enable it, so antivirus scanner, we have a number of different commercial tools here. You need to go and obtain your own licenses. We also have a version, or we'll be putting out a version with the trial stuff. Distributing antivirus software, obviously, for the commercial stuff is problematic for us. For example, if you want to do the McAfee stuff, you have to actually go and download the McAfee, install it yourself, and then it's good to go. If we go, so log to timeline, Dave had his time filter within his tool. If you only want to process or capture a certain time frame, you can add that in here, or you just go the whole shotgun approach and just absolutely grab everything. Bulk extractor, you can run your keyword in. I'm not sure how familiar people are with bulk extractor. Yeah, thanks, JJ. I've got to stop looking at the questions. Start getting distracted again. So with bulk extractor, if you're not familiar with it, it's a tool written by Simpson Garfinkel. He originally wrote it just as I guess an academic exercise to make a point. And it's a tool that I must confess, when I first heard of it, I thought, yeah, what's the point? There's lots of better ways of doing that. Having actually seen it used in this environment, it's actually really useful, and I'll show you when we start looking at the results some of the way it can be used. But we can plug in a keyword list. You can put in a whitelist of stuff you want to ignore. It is multi-threaded, so you can tell how many processes you've got, and you can select to disable the different things you want to search for. So basically all bulk extractor does, it processes the disk as a raw block, doesn't look at the file system at all, and goes through and pulls out all this stuff. So it's a bit more than just normal carving. There's a quote a while back from someone saying, you don't carve for files, carve for artifacts, and that's really what this is all about. Search for hyperfiles, search for JSON data, search for email addresses, GPS coordinates, AES keys. Zip stuff is actually really impressive. He does check for zip bombs, but with the zip stuff, he finds a zip file within the image. It will be unpacked so that it'll then keep searching inside the zip file, or even zip file fragments. it can actually partially unpack or unpack the fragments of them. So this tool, I mean, it's worthwhile checking out. Does some pretty tricky stuff. EXIF tool pulls EXIF data out of any files that may have it and may support it. So this is just running straight over the file system. Once we start running it, using libevf to mount the file system, if it's an AO1 file or if it's a folder or whatever, searching through the file system, basically just on extension, running EXIF tool against any files that may have EXIF data in it. Redripper is a real shotgun approach. It's just using every single plugin that is installed and running against that. The file carver, as I said, at the moment we're using Foremost, and again, Foremost supports a lot more file signatures than this, but these are sort of the main ones you're likely to carve for. And once again, you can choose a targeted approach looking for a specific type of file, or you can go for absolutely everything. Running the whole thing does take a little bit of time depending on the size of your disk image, which is why up here I have a run that's already been completed. Once the run's completed, you could just get a summary report of the different tools you ran. It tells you roughly the command that was used to run on it, information file run against and everything else. Creates a summary report giving you a bit more information on what's going on, and lets you know whether or not each tool ended successfully. Obviously, we're basically calling binary versions of all these tools from within Python scripts. So in terms of handling errors, it is quite problematic at times. But for the most part, we've got at the point now where we're handling errors. If the tool runs into a problem, we're handling it. We're warning the user and generating reports and logs that are at least moderately useful. In terms of the output just gets dumped into a single folder. So TAPEWORM output. Actually, I'll just show you the one. Okay, so this is one I just ran. So AV scan, simple report to text files of all the results. So we can get our log file, that's the big log file, short summary of what happened, gives you the command. And the important thing here is we give you the actual command that was used to run the tool or each individual tool. So from a debugging perspective, from a logging or a caseload perspective, you can look back and see exactly what happened and what got run. And if there were actually any viruses found, which there hopefully won't be because this case shouldn't have any viruses in it, you can see here the actual log reports for each individual tool as you go through it. Carving. And for here we handle using mount multiple partitions. We reference the partitions by their mount point, by their offset. And so the carve found a single JPEG in that. And again, we have the audit there. Tells us, and again, this is just a straight output from Foremost from the tool, giving us the offset where the file was found, its size, any comments. EXIF tool. And again, a complete record of what's actually been run. And this is the actual EXIF tool results. At the moment, the EXIF tool stuff's actually in a sort of vertical output. We're going to be dumping that into a CSV file, so you can dump it out into and process it in Excel. At the moment, it's sort of a little clumsy to use. Now, the Find Files of Interest is a really cool tool, and I'll just show you the other file I had. Where did I put it? Bear with me 1 second. So this is simply a text file, and the way Doug's using this is basically looking for stuff. Oh yeah, that might be important. Okay, if I see a .sle extension, it's an encryption file, might be stegonos, and then instructions on what to do if the file's been found. So basically, as you go through and do your jobs, you're creating a checklist of stuff to look for. Whereas normally you create a checklist and then you have to go through manually search for all this stuff. You're creating this checklist, and this script is going through and flagging anything relevant that it finds. So like this is a really cool thing as far as I'm concerned, because you're documenting what you want, and this is why I really liked Harlan's forensic scanner as well. Same sort of concept. As you find something new, you're chucking it in here, and then it's providing you with documentation of what you're looking at. It saves you remembering all this stuff, but it's also automatically dumped into the tool, so you're going to find it all the time. If that makes sense. I hope it does. Log the timeline. We actually process that, dump pretty much everything out, create body files as well for your sleuth kit, and your CSV using FLS to dump all the file system times as well. So it's actually a super timeline. So in terms of creating a super timeline, it is actually simply a matter, what's the find the right one, of clicking the button. This is really push button forensics, guys. Click the button, enter in your date, and you'll have your super timeline as a CSV straight out here. So this is all open source. All the scripts are out there, so if anyone else wants to grab that and use that in another tool, they're obviously free to do so. With volatility, what we're doing is actually dumping, if you find a Hyper file, we are going to be automatically decompressing it. At the moment, the decompression is a bit hit and miss. So at the moment, if we get given a decompressed Hyper file or a straight memory image, we can go through it and process that. Part of the files of interest actually looks for a Hyper file, gives you a warning that you can look at that, decompress it, and run volatility against it, and try and work out the right profiles. Obviously with this, the profiles, identifying the right profile can be a little challenging at times with volatility. So at the moment we're sort of trying any profile that seems to fit the image. We're going to incorporate a bit of stuff from RegRipper there to actually identify, hopefully get to the point where we can identify the operating system really accurately. And RegRipper goes through and just, as I said, pulls out, dumps out everything from all the plugins you have installed. So you can obviously go through there and remove plugins if you want to only have a targeted approach. With this, in terms of time, it takes a little while to run. You're doing a full carve, bulk extractor. Basically, with foremost and bulk extractor, you're carving the disk twice. These are two totally different tools. Trying to incorporate them into a single thing is far more programming work than we have the time for. So it is, I guess, inefficient as far as that's concerned, because you are not parallel processing everything. So the actual time taken to run sort of all the RegRipper plugins is pretty trivial. It doesn't take too much time. So that's the tool. Hopefully some people can find it useful. And again, it's just automating all the tedious stuff that you would normally do at the beginning of an analysis, and sort of go through, and a lot of stuff you go through and do it manually, automates it all through for you, so you can just go through and actually get straight to work rather than manually going around messing around with a bunch of stuff. So that's it. Not, I guess, nowhere near as pretty as any other tools we've seen tonight, but you get that. If you want to download it, the URL is just feed the tapeworm. And at the moment, you just have to send an email in to get it. We're actually setting up forums and things to support it as well. Jonathan, any plans for config files? Yes, we do. We're actually working on basically creating, we're going to call them profiles. So you would actually go through and run, hang on a sec, I'm just going to stop sharing this. Actually, no, I can just move that straight over there. You guys can see my desktop, or see me again. Yeah, so we're planning on creating profiles where you would go through and yes, this is the set I would run for this type of investigation. You know, there's a lot of plans in mind for improvements. One of the improvements we've got coming shortly is some forums on the website, but we're certainly very keen to hear suggestions and ideas for other stuff it could do. So let me know, certainly, if you've got any suggestions or ideas. I think that was the only question. Okay, so with that, I think we will call it a night. Thank you everyone for coming, and thanks especially Darren, Dave, and Joachim. I think it's great to see people, and I think especially the other guys, we've seen some really, really impressive tools out there that, you know, these guys are putting a huge amount of time in and just giving them away for free, which is fantastic. And there's functionality in sort of, especially the tools we saw tonight, there's functionality in those tools that you do not get in, as far as I'm aware anyway, that you don't get in commercial tools. There's nothing out there doing the stuff that these guys are doing. So it's great. In terms of when the videos are going to be available, I still have to do the one from last time. Sorry, Dave, if you're still there. I haven't actually recorded that. And Alyssa, too. I saw you there as well. I have been a little hectically busy lately. I will probably get it done. I'll try and get it done before I go to PFIC, but it might be done after that. So it could be 3 weeks.